Hi, here's Cupid. AI is one of the very hot technology right now that you can find a lot of material, information, and content to be trained on this topic. But most of them are targeted for the professional who has certain background and experience. Have you thought about how to explain AI to a kid? I got a chance to bring my family to Hershey Park in Pennsylvania. For those who haven't been to Hershey Park, this is another theme park which has rides. A ride means long line in waiting. And then out of the blue, when we are waiting in the line, my son asked me a question. Hey dad, what are you doing at work? You know what? At work, I'll help my client to define the KPI, and then we'll try to use some maybe naive base to predict the outcome. And if the result is not good, we may need to build a neural network and see and test it again. Do you really think that's the answer I gave my son? Of course not. Not because what I said is wrong, but because he is not the right audience to understand what I'm talking. So I'm thinking another way to explain to him what I'm doing at work and explain what is AI in the language that he can understand. So I tell him, hey son, let's think about this. If you have a computer that can do works for you, and then no one would know that either you or the computer is doing that work, then that's the AI. In fact, this is not the theory that I come by myself. It's Alan Turing, one of the very first principles about AI. He proposed it. But after my son heard this, he was asking me, hey dad, does that mean if I do the homework by using AI, that means the computer do the homework for me, my teacher would not know that it's not me doing the homework. Is that what really AI is? It's kind of the concept, but in order to correct his concept, I elaborate more. So let's think about, do you remember how did you teach your younger sister what is a pen versus what is an apple? You bring up a pen, hold it in front of her, and tell, pen. And hold an apple and put it in front of her and say, apple. You keep repeating pen and apple, bringing different pen and apple. Sooner or later, you would hope she would get that the long pointed thing is a pen. And the red rounded thing is an apple, right? So, long, pointed, round, red. Those are called feature in machine learning or AI machine learning. And pen or apple is label in machine learning. And if we combine all that, this is supervised learning. So you keep on bringing stuff in front of a computer, and hopefully the computer will recognize different features associated with different labels. And then he said, Dad, I remember, you tell me this song. Is this guy talking about supervised learning as well?
I have a pen, I have an apple, apple pen. I have a pen, I have pineapple, pineapple pen.
Of course, this song is funny, but it has no way related to supervised learning. But if this is the song helping a kid to remember what is supervised learning, let it be. In real world, supervised learning helps a lot of different fields. One of them is to help a computer to recognize what is a cancer cell versus a normal cell. In this case, the computer is the kid. The doctor is the parent teaching the computer where is it having the cancer cell. And then by practicing like multiple times, the computer will understand, oh, when I detect this pattern, I know this is a cancer cell. So by doing that, Supervised learning is very helpful in computer vision. You may have heard about the law of entropy or the second law of thermodynamics. I'm not going to pretend I'm the expert and try to remember all kinds of formula related to that, but in general, that means unless you put in some energy to keep the situation in that current state, the whole condition will just become messier over time. That's the general idea. If you apply the very same law for a kid's playground, that means unless you really put in effort to keep the toys and the playground tidy, the toy will not just automatically go back to the same places after you play them. And at my house, this responsibility is my mother-in-law, that she is helping out the kids to keep the playground organized. And there was a time that she went to Hong Kong to taking her break. But at the same time, the playground just become disorganized day after day, to a point that my wife, it's like finally cannot stand it anymore and told the kid, I don't care what kind of way you're using, but I need you to clean this up before grandmom comes back next week. She did not give any instruction. She just told the kid, clean it up. So guess what happened in the next hour? In the next few hours, the kids put all the four wheels boxy thing in one place, and we called it cars. And then all the fluffy stuff putting together in another area, they called it stuffed animal. And then they put all the blocks which can stack up all together in some boxes. They called it Lego. They did not get any instruction or rules to find out what should go to where, but somehow they figure out the similarity and the differences between different things. And in machine learning, this is called unsupervised learning. What that means is the computer is only given a lot of data, a lot of things, and then the computer will figure out the pattern by itself. This is unsupervised learning. And in real world, unsupervised learning can be used in customer segmentation. You will throw a lot of information and data about a lot of customers. You are not going to tell the computer who should group to whom, with whom, but somehow this will be grouped together by unsupervised learning. Traditionally, this is done by the expert. He or she will observe different patterns, age, like a certain spending style or spending pattern, where do you live, what's your salary, and try to group all these customers together. But by machine learning, this can be done by a machine, a computer. Of course, we need to verify that with an expert. When you deal with a kid, it's not always effective by keep telling them what is right and show them example and then say, hey, this is a pen or this is an apple, and then they start knowing and learning that through supervised learning. At the same time, it's not very effective by just giving them no instruction and let them to figure out what's the pattern behind. And another very common practice of teaching a kid is actually when they do something good, you award them. And then when they do something bad, you punish them. So this, we call it to reinforce certain behavior that a kid will perform. And in machine learning, this very same concept also applies. And we also call it reinforcement learning in machine learning. So the basic concept is the same. When a computer performs the way that you want, you add a point to the system. And then when the computer fails to perform what you want, then you reduce the point from the system. By this process, the computer will know when and what should I do in order to gain that point, and what should I avoid to do to prevent my point will be reduced by the system. That is reinforcement learning. And then in the real world example, this reinforcement learning it's applied heavily on robotics. So let's imagine a robot is trying to walk a straight line and somehow it may make it or it may fall down. And whenever there is a fall down for the robot, you reduce a point from the system. And then whenever the robot is successfully make one step, you add 1 point. So when you keep repeating that process, and since the sensor, there are a lot of sensors and motors for a robot. So and all those collect all the data to the system. As the machine learn what kind of motor speed, what kind of angle that it needs to perform in order to keep it running or walking in the straight line, then this will be the positive reinforcement to help it to keep doing that. And then whenever that certain angle or certain motor speed is going to trigger a trip for the robot, it will learn to avoid doing that. So that's the reinforcement learning in the real business use case. So what we have covered so far, we covered the supervised learning, unsupervised learning, and reinforcement learning. But that's not all. When you teach the kids about supervised, unsupervised, and reinforcement learning in different ways, when they grow up, they start asking a lot of different questions. And I guess two of the very popular questions they always ask, especially when they see the stranger on the street, very embarrassing, is they will ask the stranger, "How old are you? And are you a boy or girl?" Yes, that happens when the kids start talking and realize they can ask questions. But do you remember or do you recognize these two questions actually are falling into two very key methods in machine learning? That is, when you ask, "How old are you?" It's asking for a number. It's regression. It's a method really to predict the number as an output. And at the same time, when you ask, "Are you a boy or a girl?" It's a classification problem. It's a classification approach in machine learning to find out or predict an outcome for a predefined category, a boy or girl, or what kind of color it is. So those two questions reflects also the two very significant way or approach in predicting for machine learning. Here is how a kid learns. They observe the world around them, and then they think and they come up with certain rules in their little mind. And when they see something new, they will come up with the result. You as a parent may say, "Yes, this is true, this is right," or "No, this is not true." So they will correct or modify the rule in their little brain to become better and better again in the future. And let's compare that to the old way of programming. A developer will also observe the world, and then instead of just keeping in their head, they will code. They will use some like a rule-based algorithm to code it, and then they will come up with some result based on that kind of rules, preset rule in the programming. And then they will review the result and see if the result is actually matching up in the future or not. If yes, they continue to keep the rules, or if not, then they will change or modify the rule to make it more realistic in the future as time goes. That's the old way of programming. However, in AI, it's a little bit different. It's not just coding the rule. As a developer, we will develop the AI algorithm to handle the ruling part, meaning that we will bring in data, we will collect the data, and then we develop the AI algorithm and let the algorithm to come up with a model. We call it to train the model. As the model develop and try to make a prediction to get the result. We will then test it back to see if the result is accurate or not. But the key here is the algorithm itself will keep modifying the model without really the developer get involved. So that's the beauty of having the AI algorithm instead of a human to keep modifying the model. Finally, let me ask you a question. What is the difference and similarities between Tesla and Uber? They both use AI, I know, and they both related to car industry. That's the similarities. But the real difference is one company, Tesla, create new technology to help revolutionize the whole car industry, while Uber, they use some existing technology, web app, mobile apps and map to create a new business model in the car industry. So why am I saying that? Simply because when we are thinking about machine learning and AI, many classes, as I explained it in the earlier of this video, they are teaching you the algorithm. How am I going to write AI algorithm, machine learning algorithm? They are trying to teach you the technology. Maybe if you're interested in this field, you can invent more and fine-tune more algorithm to make sure that the data will fit into that. So that's the technology, that's more the Tesla approach. But if we have already got so many different algorithms available to you, or maybe built by someone else, that's fine. If you can really get use of this algorithm and then get the business case to build a business case and produce a business value, that's another way of how do you approach machine learning. No right or wrong, it just depending on your passion and what kind of direction you want to go for. Do you remember when I explained to my son what is AI? His response was, does that mean the computer can help me to do the homework so that my teacher would not know? Of course, I know. From the bottom of my heart, I would be very proud of him. At his age, he can come up with a sophisticated algorithm that can fool his teacher. But at the same time, I would be equally proud that he can find out some algorithm developed by someone else that to fool his teacher. One is he built the algorithm, that's the technology part. On the other hand, he utilized the technology or algorithm developed by someone. In this video, we cover the very basic yet very key concept in AI. If you like it, please subscribe my channel below and like this video. And then next time, I'm going to cover more technology in the language that you can understand, just like how I explain AI to my second grader kids. Until then, see you next time.